This activity is called spray bottle, and it's about systems that use a piston pump to move liquids through a piping system. There are 6 purposes for this activity. Number 1 is to practice learning by doing. The best way to learn fluid mechanics is to do real fluid mechanics. The second is to practice knowledge construction, or KC. And KC is a process of acquiring knowledge so it's useful. The third is to practice idealizing real-world systems. The fourth is to practice applying physics to real-world problems. The fifth is to practice designing an experiment. And the sixth is to practice reflective thinking. Let's get going, and we're going to first look at a common commercial product called a water pick. This device is called a water pick. It is used for cleaning teeth. When we turn this on, we can create a high-speed fluid jet out of nozzle, shown here. Turn that on and off. This sketch shows an idealization of the water pick. So the water reservoir here we idealize with a water reservoir, and there's a drain right here connected to tubing, and the tubing goes down to a pump and motor down in the body, and so we show a pipe, we show a piston pump to represent the pump used in the water pick, and then we draw another pipe to represent all the tubing in the water pick, and then finally we show a nozzle. There's also a valve in this line which I did not draw. It turns out that this basic idealization works for many real-world systems. For example, a paint sprayer would work very much the same way. And another common device, which we're going to look at now, that operates on the same principles, is the common spray bottle. We've all seen spray bottles. Taking this apart, we can see a bit about how it works. Water comes in this end. There's typically a screen. It moves up the tube, and the handle activates a piston pump. And you might be able to see it moving there in the video. And there's a couple of check valves. And in the water in the spray bottle is directed out the nozzle. Let's look at the spray bottle in action again. Let's look at your tasks. In step 2, get on the internet and find answers to these questions. So, how exactly does a piston pump work? What are check valves? How do they work? How does a spray bottle work? In step 3, create your idealized model of a spray bottle. How would an engineer idealize or approximate the performance of a spray bottle? Step 4 involves experiment design. As engineers, we figure out how we're going to do an experiment, and we do this on paper before doing the experiment. Some of the questions you want to consider is, how is efficiency of any system defined? How am I going to determine efficiency of a spray bottle? What instruments or devices can I use, and what steps will I take to get data? Step 5 is the fun one, execution. So go ahead and run your plan from step 4 and take data and then determine the efficiency of a spray bottle. Some questions you want to address as you discuss your results are, how good are my results? How did I validate? What are the uncertainty? What factors are influencing the efficiency of a spray bottle, and why? The last step is reflective thinking, and there's 2 kind of things you want to think about. What did you learn about fluid mechanics while doing this activity, and what did you learn about doing engineering? The performance goals describes how we do engineering, and it also describes how you get graded on this. So when you're doing knowledge construction in step 2, you want to find useful knowledge. You want to communicate this in super simple ways using your own voice. When we make idealizations, we just simply do real simple line drawings like textbooks that show our assumptions and how we're going to represent things. When we do experiment design, we always start with the fundamental physics. And then we design experiments that can be done real simple, real low cost, real fast. And we structure our process using the Wales Woods. No surprise, we define the situation, state the goal, etc. When we do reflective thinking, we're trying to find useful ideas and then develop this idea and explain it to other people, and then trying to make the idea generalize so the idea is useful to us and other people in many contexts and many situations. Reflective thinking is a key part of learning. All right, go ahead and get started on this activity. Remember to have fun and do the best you can, but keep it simple and keep your time to about 2 hours on this.